Hello y'all. We're going to be doing the cross-cloud model training and serving with Kubeflow workshop. I'm going to be running through the workshop so you can see a solution of it hopefully working. And you can also see that, there's a take 4 number up in the top here. If you run into problems, do not worry, you are not alone. We've done our best to fix the problems that we know of, but we also have this shared notes document where we document some of the problems that you may run into and their solutions. If you run into a problem, definitely, please do jump in and leave them here so that people can see your solution. My Hello Kitty ears are not super visible. Oh well, that's all right. So what are we gonna do? Okay, here's our README. So there's this motivation part. Says more or less that we picked a simple problem so that we can focus on the cross-cloud components of Kubeflow. There's a debugging guide for when things go wrong. Hopefully we're not going to need that, but realistically, we probably will. So we're going to go ahead and just get started with the setup. The first thing we're going to want to do is log into the Cloud Console. Now, I'm already logged in, but I have multiple accounts here. So I've got Holden, Programmer Boo, and DevStar. You too can come and talk to the TAs and get one of these lovely sheets of paper, and it'll have usernames and passwords on it, and you'll log in with one of those. And you want to make sure that you are in your CodeLab account. So we can see here, when I do that, I get this, I don't have sufficient permissions to view this page, and that's because this is pointing at the project in my other account. So what we're going to do is we're going to go in and we're going to select the Kubeflow Strata project. Okay, so we've done that part, logging into Cloud Console. Now we're going to connect to our Google Cloud Shell. And this is really convenient. I want to be clear, you don't have to use Cloud Shell to use Kubeflow. It's just to save us the time from having to set up Kubeflow on everyone's machines. We're going to use this Cloud Shell environment, which is common for everyone. And that's really exciting. We're going to want to enable boost mode. Boost mode is apparently just like hella enabled. I can't even turn it off. So that's kind of cool. Yeah, I don't have anything there. Optional, we can use screen. For the most part, I recommend skipping the optional steps unless they really speak to you as something that you want to do. Screen isn't all that hard, but if you don't already know screen, this isn't really a workshop about using screen, so you probably don't want to do that part unless you're really excited about it. So we're going to go ahead and we're going to download this fast start script. And this fast start script will set up and install all of the things needed to run Kubeflow on top of on GCP. So this will set up let me hit start because it's going to take a while. And then we press enter again to confirm. And so what this is doing is it's installing all of the dependencies, it's downloading Kubeflow version 0.4.1, it's downloading CaseOn net, it's enabling the different services that Kubeflow depends on. Now, when you run this, that will take much longer than this one did, quite likely, or it may, essentially just because I have some of these services pre-enabled on this account, and they might not be enabled in your account. So this part could take a little longer. Don't get worried about that. Okay, cool. We're creating a deployment now. And this part is going to take a while. So while it's running, it can be a good idea to read ahead and sort of see what's going to be coming up to us. So we're going to load a Kubeflow application. We're going to look at this thing called the Ambassador. The Ambassador is really cool. It gives us a nice web UI, but it also routes serving requests. So that's going to be very useful as well. We're going to install some extra components. And then we're going to go ahead and download this thing called Argo, which Kubeflow pipelines are based on top of. But since Kubeflow pipelines are GCP only for now, and this is a cross-cloud workshop, we're just going to use Argo until that bug is fixed. We're going to train a model. We're going to go ahead and serve it. There's a lot of things in here that are optional, and once again, I encourage you to skip it unless you really want to do this part. And it's, for example, you can change the kind of model that you're training in here. And then there's this monitoring step and serving and querying. So we'll go ahead and we'll query that. And that'll be very exciting. If you wanted to do it with Azure, there's some instructions here. For the most part, people doing it in Azure are going to be on their own because we were going to have a co-presenter from Microsoft, but unfortunately, she was double booked by O'Reilly. So, you know, I use Azure, but I work on GCP day to day, and we might not have the Azure experience. So then once we're done here, we're done with GCP, you can go ahead and train or serve on top of IBM. That's going to be the cross-cloud part, and that's going to be very useful. So let's see if that filled enough time. No, we are still getting our cluster creating. So I'm going to bring that screen up, and we're just going to sit here and wait. And that's going to take a hot minute. And that'll be cool. There we go. And so that's good. It still takes a while to create our cluster. So while it's making the deployment, we can go in and we can start looking at some of the components that it might be creating. One of the things that I would expect it to create is a Kubernetes engine, and we can see a GKE instance, Google Cloud Kubernetes engine, and we can see that a Kubernetes cluster is indeed coming up. And so that's pretty rocking. And I'm just going to let one of my co-presenters know. Sort of the state of the world, namely that I'm doing this run through right now. Yeah, okay, cool. So this is going to take a few minutes. Okay, cool. So we've got our cluster. Once again, it may take a little bit longer for you. Don't worry about that. That's normal. And now it's starting to set up some other things, so some permissions and user agents and service accounts on Google Cloud. So that'll be good. And we can see now, actually, yeah, we're connected to the cluster, and it's generating some stuff. And so this part is automated because I wanted to disable IAP. And IAP, we'll talk more about it actually while it's applying, because it does take a few minutes to apply. So we have a Kubeflow app called GKF app, and we can go into it and start taking a look around. So let's go back to our README. See what it says to do. Oh, really important that we don't skip this step. We have to source our bash RC because it adds some very important environment variables inside of it that we're going to depend on. So we sourced our bash RC. We're inside of there, and we want to source m.sh, and that's some additional environment variables specific to Kubeflow that were generated for us, and we're going to go ahead and deploy Kubeflow to our Kubernetes cluster. And so we do that with this kfctl, Kubeflow control, apply K8s. And so this is bringing up the ambassador. So let's actually Kubernetes ambassador. So the Kubernetes ambassador is an open source Kubernetes aware API gateway for microservices built on Envoy. And we use it to expose things like the web UI, the web UI of Jupyter Hub, TF Board, and all of those sort of helping tools. I don't want push notifications. That sounds like a terrible idea. I don't understand why websites try and give me push notifications. I don't want them ever. And it also lets us make requests to the different serving backends without having to manually go in and expose each of them. Okay, we're setting up Jupyter. Most of you are probably fairly familiar with Jupyter. If you're not, it's the evolution of IPython notebooks. Okay, TensorFlow, dashboard, TF job operator, PyTorch operator. And so this is applying sort of the default list of components. And there are more components. In fact, we're actually going to install one of them next. Or maybe not next, but soon. We're going to install this meta controller. Very exciting. I'm going to try and stop fidgeting because I know that picks up on the microphone. Spartacus does reporting about usage, I think. I think that's what it does. Argo is the pipeline system that we're going to use. There is a fancier version built on top of Argo called Kubeflow pipelines, which hopefully in the future is going to be the one that you're going to want to use. For now, we're just going to use Argo directly, and we can see now we're deploying the fancier Kubeflow pipeline thing, and that's the one which only works on GCP for now. There's essentially two outstanding issues, and they're both being worked on actively, and then hopefully soon that'll be resolved. Bunch more things were deployed. I guess we didn't. Okay, now we're doing Katib. Katib is really cool. You can use it for hyperparameter tuning. Very useful. Very useful. And it doesn't work just with TensorFlow. It works with different kinds of things. So it's general purpose, and it really sort of shows the benefits of using a system like Kubeflow. Honestly, I don't remember what our cloud endpoints are. It's probably something to do with cloud endpoints. Cool. What does it say? Cloud endpoints controller. Doesn't really say. Certificate manager, because no Kubernetes cluster is complete without 7 different SSL certificates at the minimum. Ooh, I should have gotten myself more coffee. Okay, and IAP ingress. Now this is a component which is being deployed, but to a large extent we've disabled it. And that's because while IAP ingress is really amazing, so it's called Google's Identity Aware Proxy, it can take up to 20 minutes to set up. So we skip that because we only have a few hours for this tutorial, and the extra 20 minutes seemed not very worth our while. It is a great thing. It makes it very easy to get to your Ambassador web UI, among other things. But while it takes 20 minutes in the happy path, the problem is if you make any mistakes, it's incredibly difficult to debug, and we didn't want to spend all of our time debugging a web proxy when we're supposed to be working on machine learning tasks. So you should definitely use IAP in your own clusters. It's worth the time to set up, but not for this workshop. Okay, cool. So it's a list of Kubeflow things. We're going to go ahead, look for the ambassador just to make sure. Cool, the ambassador is deployed. That's great. And we're going to go ahead and port forward the ambassador in. And now this goes to the Cloud Shell. Very convenient, and we can go ahead and we can use this fancy web preview, which will actually do a proxy into our Cloud Shell instance, and then we use the kubectl proxy to get to the ambassador. And this is the web UI. There is more to the ambassador than just the web UI, though, as we've discussed. It's also used for routing requests. So we're going to go ahead and install the package called Selden. Or more accurately, the component called Selden is already installed. We're going to have to go inside of the KS app directory. And then we're going to look at the components that are installed, make sure it's installed, or packages. KS package list. Okay, cool. Yeah. Interesting. I think this is because I've run this multiple times, but we can see that Selden's in here somewhere. Yeah, Selden's in here, and in fact it's installed. There's the little star next to it. So that's convenient, but just because the package is installed doesn't mean that it's actually deployed to our cluster. So we're going to go ahead and generate a component for it. So we've got our prototype. It's called Selden, and I'm just going to give it the same component name as the prototype or whatever. Selden, sure. We can list our components now. And we can see, yep, Selden's installed. That's great. And then we can go ahead and apply it to our cluster. Cool. And so this KS application is from this thing called CaseOn, which is deprecated, and Kubeflow will be moving away from. So these parts of the sort of workflow will change in the future, but for now it's what we do. To verify that it's been deployed, we're going to get the CRDs, and we're going to make sure that Selden shows up in the list of CRDs that we get back. It's okay. Looks like my copy and pasted the wrong thing. Get CRD, and we can see Selden showed up in here. Cool. Great. And we can see, in fact, that it has a slightly different deployment time. Most of the other ones are clustered a few minutes earlier. There's some optional steps here. I encourage you to skip them unless you're really excited about them. So we're going to set up Argo, and Argo is not the way that you will be doing this in the future. Most likely you'll probably use Kubeflow pipelines, but for now, to keep it cross-cloud, we're just going to directly use Argo, and we're also going to use this very broad permission scope, and that's just because this is like sort of a temporary workaround for the current released version of Kubeflow. Now we're going to want to create a persistent volume, and it gives a place for our models to live after training. And so we're going to go ahead, create our persistent volume claim. Now one thing is persistent volumes aren't portable across cloud providers, right? At least I don't believe they are. So while this is going to work while we're on GCP locally, we're going to have to take some steps in part 2 of this to get our data out of the persistent volume and put it somewhere that we can access it across clouds. So we've got our NFS mount. That's great. Okay, cool. We're going to go ahead and go here. We're going to clone the example that we're going to be using. We're going to be using mnist, and we're going to do SKlearn. Now, thankfully, and there's this optional component where you can monkey around with the existing model. That is, you can train different kinds of models. You can swap SKlearn around. We are not going to do that in the workflow because I want to get finished quickly. And I would encourage you to also probably, at the very least, first do it without monkeying around with it, and then do another one where you monkey around with it afterwards. So that's going to train a SKlearn model. I think it's random forest, and we're going to go ahead and we're going to watch the pods as they progress. And you can see the first one is running. The first one I think is the one that launches the other ones. I'm a little fuzzy on Argo pipelines. I haven't put a lot of thought into them. But that's going to go ahead and run. This is going to take a while. We can see that the pods should go from pending to container created to running to completed. We missed the pending step because I was talking probably while that container was in the pending step. So now it's just going to do the container creating step. Container creating is going to take a little while. And I believe this is because we're having to fetch the container image from public Docker repo. And it's not cached locally yet because we have a new Kubernetes cluster, and so it's having to fetch a non-trivial amount of data. I think it's doing the pull as part of this. I could be wrong. Okay, cool. And so now it's running, and so that's very exciting. And so actually, let's talk about that. This -Wflag here essentially has Kubeflow do its own internal watch. And it's really nice because it updates when the state changes rather than just updating every 2 seconds and hitting the API endpoint that way. I think it's a push subscribed. It might actually just be a loop inside which checks. But at the very least, we can see when new things change. And so that's exciting. Because it doesn't just keep printing out the same things over and over again. It just prints out the state changes, even if it is implemented with polling. I don't actually remember if it's implemented with polling or not. Training the model can take a while. And in fact, if you're doing this on IBM Cloud, you're going to want to make sure, or actually even if you're doing this on another cloud, you're going to want to make sure that you have a reasonably sized Kubernetes cluster. And that's just because, if you have really, really small nodes without a lot of CPU power, this training could take you even longer time. Cool. Storage nodes. We've got 2 nodes running. Not a lot of memory allocated. If we go into our applications, I think that's where I want to go. We've got Kubeflow. If I go to Workload, lovely, and we can actually see our workloads in here. We can see Kubeflow sktrain is running pod. Yeah, very very nice. Happy web UI. The little green check mark means everything is happy. Now that being said, you may see things like Envoy or the IAP enabler get into things like crash loop enabled, and that's just because I've disabled IAP for you, but I didn't remove the components because it's kind of annoying to do that. Okay, cool. So now it looks like it's finished, so that's very exciting. We're going to go ahead and validate that it's finished. We're going to call Argo list, and then we're going to give it the namespace Kubeflow, and that'll show us our different Argo pipelines. Okay, cool. It looks like our pipeline succeeded. No error messages there. Very exciting. We're here, so we're going to go ahead and serve our model. And this is just going to kick off another job, and we can go ahead and check to see what the deployment name is, and it's based on our pipeline. Ours should be mnist. Cool, yeah, mnist classifier, and it's existed for 11 seconds, so it's definitely the new thing that we just did. And so we can do REST curl requests. Doing them by hand is not what I would recommend. Instead, what we're going to do is we're going to go ahead and we're going to use the ambassador. I'm going to go into Jupyter Hub. I'm going to give it a name like I need coffee. Sign in. The user password is just, doesn't really do anything. A side note, if you did have IAP enabled, that username and password would actually be controlled by talking to the fancy IAP thing. This looks like pretty reasonable resources. I don't think we're going to have to change anything. I'm just going to go ahead and click spawn. Now, the spawner here, it didn't, last time I used it, it definitely did spawn the Jupyter Notebook, and we can see this warning. Please make sure that you have sufficient quotas. It just, well, we're going to see in a second that it's going to say it's going to automatically redirect us, and there's this event log. That didn't work for me, and that may or may not work. So we're going to stay on this page for, I don't know, 1 minute, and we'll see how it goes. And so this will hopefully work. If not, what we can do is we'll just go ahead and we'll click home, and then we'll click thing, and then it'll be happy. So we're just going to wait that 1 minute together. It's a very exciting 1 minute, and we're going to look at this event log here, see if anything comes up. Nothing. Okay. I wonder what happens if we do a kubectl get pods watch. Kubectl get pods, and well, let's go actually all namespaces dash watch, and we can see if something comes up. Interesting. Cube system, metadata, stack driver. Stack driver is a really useful Google tool for debugging. We can see it in our web UI here. And in fact, we can go, I don't know where it is. Where is stack driver? Tools, logging. Okay, stack driver, logging logs. And we can actually go in and start looking at things. Normally this gives me some things. Cool. These are audited resources. We don't, we actually probably care about our Kubernetes cluster, and we'll go for a Kubernetes cluster all location. And we can see all sorts of useful logging messages in here. And I think we're good here. Oh, and we can see Jupyter I need coffee. Interesting. One of them had an error, and the other one came up running. That might be why it's not working. But that's okay. I suspect that means we've got a server that we can go to. So we're going to click home, we're going to click on my server, and then we've got our server. That's very exciting. Now we could go through this, do this all by hand. That being said, there's a solution here. I'm just going to go ahead, download that solution. Query Selden 1, and we're going to go ahead and upload that solution. Query Selden 1. Press upload, and then we're going to go ahead, go in here, and then we're just going to run it. It's going to be a party. That is amazing. So run this. This installs matplotlib, so we can get a nice little picture here of our image. It does take a little while to install matplotlib, though, because it has to hit the internet. Cool. There we go. Download mnist. Go ahead, download it. Then it displays an image. Then we're going to go ahead and configure the URL that we're going to make our request to. And so we're making a request to the ambassador, which will route it to the Selden backend for serving. Get our thing, and we print our response. And it's a response, that's great. Should probably print this JSON, but like I don't have the time for that. So that's really exciting. We have now done a end-to-end on Google Cloud, I think. Let me double check if there's anything left. Oh, right, because I clicked on that. Okay, cool. We've just deployed and served and queried an end-to-end ML model. That's very exciting. But now, the next step for this workshop is going to be the multi-cloud part, where we go ahead and we try and get this working on a second cloud. I'm going to use IBM, just because that's what I'm more comfortable with, because I've been working with Trevor on the IBM serving, and as previously mentioned, perhaps, unfortunately, the co-presenter who we're going to have from Microsoft got double booked by O'Reilly, and so she's not available to help out, so we're going to use the IBM clusters.